In this work, we use correspondence learning to improve the abilities of robots to learn visuomotor policies. Often visuomotor policy architectures can be factored to have a visual model portion, which converts raw images into a low-dimensional representation. A policy model portion then combines this representation with low-dimensional measurements such as from the robot's encoders to predict an action. In our approach, we use a model trained on dense correspondence, in our case a 34-layer convolutional network, and use it to find corresponding locations of a descriptor set, which means we send images through the correspondence model and then compare with a set of descriptors to find their predicted image space or 3D space locations and use these locations as input to the policy. Recent work has shown correspondence learning to be a powerful source of supervision that robots can teach themselves. In our new work, we are able to handle learning from dynamic scenes by using a multi-view time-synchronized technique. Here are some examples of correspondences, here in a dynamic scene, here across sizable shape variation, and a variety of instances in the class. Here's a set of 9 descriptors corresponded across a dynamic scene for a deformable object that's being deformed. Note that even if descriptors are not perfectly globally consistent, they often have smooth local consistency and show compelling generalization across a variety of backgrounds, moderate occlusion, and lighting changes. To evaluate our general approach to learning visuomotor policies, we use imitation learning. Note that all the following videos are autonomous. Our learned policies perform real-time vision-based feedback on monocular RGB images with as few as 50 demonstrations and can manipulate deformable objects and generalize across categories. To compare against baselines, we use simulation experiments on a handful of reaching and pushing tasks. Here's an example of what a failure looks like on one of these tasks. Please see our paper for more details.